All right, so this is our last section in Chapter 6, or Unit 6, quadrilaterals in the coordinate plane. What we're going to be doing in this lesson is taking 4 vertices, 4 points, and plotting them on a graph, and figuring out what kind of a quadrilateral it is. That's one thing we're going to be doing. Now, in order to figure that out, since things are going to be graphed on a coordinate plane with x, y coordinates, we'll be using our 3 formulas: distance formula, midpoint formula, and slope formula. Okay, the other thing we're going to be doing is proving facts about certain quadrilaterals. So to do that, we're not going to be writing flowchart proofs. We're not going to be doing 2-column proofs. We're going to be doing what are called coordinate proofs. And it's not going to really feel like a proof, I promise. It's really more about algebraically showing your work, and then that's basically the proof. Okay? So it's a new kind of proof. It's coordinate proofs, and it's basically just doing some algebra. The difference is, between the 2 things that I said we're going to be doing, figuring out what kind of a quadrilateral it is, we'll be using actual numbers. It'll be like, here's the point -4, 2, and the point 8, 7, and whatever. 4 points, connect them, figure out what kind of a quadrilateral it is. When we're doing coordinate proofs, we're not going to be using actual numbers. We're going to be using variables. The reason we use variables, because when we're proving something, we need to prove it about all cases. So like if we're talking about an isosceles trapezoid, we want it to be true for all isosceles trapezoids, not just one particular one that we happen to graph on a coordinate plane. So that's why we have to use general variables. Okay, I think you'll understand more what I'm talking about as we go through the lesson. You remember these 3 formulas? Distance, midpoint, slope. What do we use distance formula for? Okay, to find a distance, to find the length of a segment, right? So the distance from one point to another point is also the length of the segment with those 2 endpoints, right? So we have to remember that when we're talking about quadrilaterals, the distance formula is going to help us find the length of sides or the length of diagonals and be able to compare them. Midpoint formula, remember, is the average of the x's and the average of the y's. This is helpful to prove that diagonals bisect each other. Because when we draw the 2 diagonals of a parallelogram, what should be true about that point? If diagonals bisect each other, that's the what? The midpoint. The midpoint of both diagonals. Okay, so we'll see how that's applied later. The slope formula. What happens if 2 lines have the same slope? What do you know about those lines? Parallel, right. Same slope means the lines are parallel. And if they have, what if they're perpendicular? Opposite reciprocal slopes, right? So opposite reciprocal slopes are going to be like 1/2, and then the opposite reciprocal will be like -2, right? So when we talk about quadrilaterals, think back to the properties of quadrilaterals. Can you think of any properties that talked about perpendicular? Rhombuses had what? Perpendicular what? Diagonals, right. Good. Kites have perpendicular diagonals. So you can see that using the slope formula is going to help us figure out or prove that diagonals are, let's say, perpendicular. If you think about the definitions of all of our quadrilaterals, Was the word perpendicular in any of the definitions? Like, I don't think we actually had the word perpendicular in any definitions, but what does perpendicular mean? They make right angles. So squares and rectangles have right angles, right? So if we can show that sides are perpendicular, that's the same thing as showing that they have right angles. All right, so coordinate geometry is basically taking shapes, figures, and putting them on an XY axis. And we do this, we're going to label the coordinates using variables. Now, what we want to do, and this is kind of a strategic thing here, and there's different ways of doing it. What we want to do is think of the shape that we want. In this first one, we wanted a right triangle. Well, in order to guarantee that when we plot these points on a coordinate plane, that it's a right triangle, we can make it so that the right angle is right at the origin. Because we know that the x-axis and the y-axis meet at a right angle, right? So putting the right angle there guarantees that that's what it is. Now, we need two other points. This point here, they have labeled as the point B0. Because we're using variables here, they're using A and B. So this is the point B0. This point is the point 0A. So, what is this length? What is the length of this segment right here? B. That's the length of that segment. How do I know? Because in order to get to this point, I have to go a distance of B to the right, and then up 0. Right? The point B0, that's what that represents. What is the length of this side of the triangle? A. Because we went to the right or left 0, and then up A. Now, why didn't they just do B0 here and 0B again here? How come we needed a new variable here? Cooper? Yeah, because in a coordinate proof, if we're trying to prove something about all right triangles, we can't make it special. You can't make it isosceles, because then whatever you're proving might only be true for isosceles. You have to keep it as general as possible. So you got to kind of figure out when you need to add another variable in there. Okay, the next one is a rectangle. Again, push the right angle up against the origin, and you're guaranteed it's a right angle. 0, 0. This is the point B0, so this length is B again. This height is A. Well, if that's true, look at the points, the coordinates of this point. BA, because we had to go over B and up A to get to that point. That make sense? So far, so good. Okay, isosceles triangles, you want to make sure these two are the same length. So if this is 0, 0, and to get to this point, I have to go over C and up B. That means this distance is C, and the height is B. You see why this point is 2C? Right? In order for this to be an isosceles triangle, that altitude that comes down has to split that base in half. So if this distance is C, the next distance is C also, and so the whole distance is 2C, and that's how they got that variable there. Okay, this last one is a trapezoid. We've got the point 0, 0. They labeled this point C0, which means this whole distance is C. They labeled this point AB. So what would you say is the height of this trapezoid? What's the height of this trapezoid? As a variable, what is the height? Yep. Not A. To get to this point, I would have to go over A, right, and up B. Good. So B is the height. So do you see this little distance right here is A? Well, if this is an isosceles trapezoid, that means that this distance here has to also be A. Right? In order for it to be isosceles, those two pushouts have to be the same distance. All right, so that leaves that. To get to that point, we have to go over this far. Well, we don't have a variable for that. But it's related to the two variables we already used. Because to go this far, what do we have to do? Ryan, what were we going to say? Oh, okay, I thought you were. Yeah. Yeah, so if we go all the way to here, we get to C. But we only want to go to here. So we have to go C and subtract A. So in other words, this distance is C minus A. So that explains the x-coordinate. C minus A is that distance, and then still the height is B. Okay, so let's look at number 1 here. We'll start easy. If this is a square, we know all the sides are the same length. They're telling us SQ is 2A. So then, what's this length? 1A. And what's this length? 1A again, right? That's the length there. Okay, but what we want to come up with are the coordinates of the 4 points. Knowing that every side of this square has a length of 2A. So try doing that. All right, so what'd you get? For Q, what should be the coordinates? A, over A, up A. So A. What is R? A negative A, exactly. Over A and down A, right? Okay, what about S? Negative A, and whatever this is, that E? Both negatives. Negative A, negative A. All right, let's look at the kite. They give us all this information. The length of IE is 2A. IE is 2A. KO is B. And OT is C. Figure out the coordinates of KITE. All right, so what'd you get for K? Good, negative B, 0. Because if this length is B, you have to go to the left B from the origin. Always start at the origin. So negative B and up 0. What about I? start at the origin, go right or left, nothing, good, and up A, positive A. What about point T? Over C, up 0, good. And E? 0, negative A. In this example, we have a parallelogram. What is the length of this parallelogram? What's the length of that side? 2A. What is the height of this parallelogram? 2C, good. So 2B is just this little piece right here. And if it's a parallelogram, this piece and this piece will be the same. So again, that explains that coordinate right there. To get to this corner, I have to go over the 2A plus 2B, and then up 2C. Now, you might wonder, why did they use 2A and 2B and 2C instead of A and B and C? And it's because in this particular example, they want to find the coordinates of point D. If this is a parallelogram, what formula could we use to figure out the coordinates of point D? Midpoint. D is the midpoint of the two diagonals, right? So to get the coordinates of point D, we would use the midpoint formula. Well, the midpoint formula looks like this. Right, where we're finding the average of the x's, the average of the y's. We're dividing by 2. So they purposefully made all of their coordinates times 2, so that when you divide, you won't get a fraction. Right? Because if I take half of 2b, it's just b. If I had named this b, c, then when I did half of it, I would get a half b and a half c. And that's just annoying. We don't want fractions if we can avoid it. So that's why they multiply by 2 for all of their coordinates. All right, let's look at number 5 here. CBD is an isosceles right triangle. Well, we know it's a right triangle because it's in the corner there. They're marking these to be isosceles, so you need to come up with the coordinates of D that would make this an isosceles right triangle. I'd like you to try number 5 and 6. My video. So I'd like you to try 12 through 15. I'll do number 12 with you. Keep in mind that anytime you have a trapezoid or a parallelogram, there's one vertex that's really dependent on the other ones. And that's the one that gets a little bit tricky sometimes. And notice in this diagram, they're saying it's an isosceles trapezoid. So you know these two lengths are the same. If that's true, that means this piece here is the same as this piece right here. If point L is here, and it's A plus B, 0, and M is at the point A, C, here's my question. What is the distance from here to here? That length there has to be A. In order for M to be over A and up C. So the height of this trapezoid is C. Over A, up C. Okay, so if point L is A plus B, then what's this little distance right here? B. Okay, so finish 12 through 15. We didn't finish 12 yet. Finish 12 through 15. Ask questions if you have them, and then we'll go over it. All right, so let's go through these answers and see how you did. To finish this one off, number 12, we know the height is C, so N would be 0, C. Right or left 0, up C. K would be what? Negative B and up 0. Right? Number 13 is an isosceles triangle. If E is at A0, that means this length is A. That means this has to be A. So D would be negative A, 0. And F, we're ready for a new variable. Because this length of F has nothing to do with the lengths that are A. So we're going to go over 0 and up, let's use B. Number 14, this one's a little bit tricky. If this point R is at A minus B, that means this distance is A minus B. That's what it says. We have to go over A minus B and up C. Well, if that's A minus B, then the whole thing must be A, and this little piece must be B. And if it's parallelogram, this piece has to be the same as this piece. So S is negative B, C, and Q is A, 0. All right, 15. B is going to be A, 0. Which one are we doing? 14?
Oh, I thought Q was.
No, because it's naming the 4 vertices. Okay, so B is A, 0. F would be negative B, C. And D would be A, D. Any questions on those? All right, so we're ready to actually write a coordinate proof. We're using a coordinate proof to prove something like a theorem or whatever, just like we used other proofs. But this does not look like the other proofs that we've done. We are going to prove the trapezoid mid-segment theorem. Well, the trapezoid mid-segment theorem said, if you join the midpoints of the two legs of a trapezoid, that's called the mid-segment. What were the two things that were true? Okay, the mid-segment is the average of the two bases, right? So in other words, MN is 1/2 OP plus RA in this case, or the way we thought about it, 2 times the mid-segment, so 2 times MN equals OP plus RA. See how that's the same thing? All right, so that's one thing. What was the other thing that happened when you draw that mid-segment? It's what to the other two? Parallel. So the other thing we're going to prove here is that these things are all parallel. That the mid-segment is parallel to both bases. All right, so let's think about our formulas. If we're going to prove things are parallel, what formula are we going to use? Proving things are parallel, what formula are we going to use? Slope formula. Same slope means parallel lines. Okay, if we're going to prove this, 2mn equals OP plus RA, what formula are we going to use? Distance. We need the lengths, right, to show that this relationship is true. All right, well, in order to do slope formula or distance formula, we need the coordinates of m and n. Okay, I'm going to warn you right now not to write too big in this space. We kind of have a lot to fit in there. So kind of write small. All right, so the first thing we're going to do is find the coordinates of m and n using the midpoint formula. M is the midpoint of RO. Midpoint formula is the average of the x's and the average of the y's. So if we're going to use the point R and O, the xy of R and the xy of O, we have to add the x's. What do we get? We're using these coordinates and these coordinates. I guess we could write them as 0, 0. Now we're going to add the x's to b plus 0 over 2. And now 2c plus 0 over 2. That gives us the coordinates of m. Well, 2b plus 0 is 2b over 2 is just b. And 2c plus 0 is 2c over 2 is c. So the coordinates of the midpoint, m, is bc. All right, now we need the midpoint of the other leg, which is AP. And that's point N. And we're going to do 2D plus 2A over 2 and 2C plus 0 over 2. And we get the coordinates of N. Well, what's 2D plus 2A all divided by 2? D plus A. And what's 2C plus 0 over 2? All right, so we have to start with those coordinates because we're going to need them for using in our slope formula and our distance formula. All right, I'm going to draw a little line here because now we're going to go into what we're proving. Switch colors. First thing they want us to prove is that MN is parallel, to OP, and MN, this mid-segment, is parallel to RA. Again, what formula are we going to use to show things are parallel? Slope. So let's find the slope of MN. Remember, slope is y2 minus y1 over x2 minus x1. Up here in our diagram, we're doing the slope of MN, so we're using the two coordinates, the two ordered pairs, I should say, of M and N. So subtract the y's. So we've got c minus c over d plus a minus b. Doesn't really matter what's on the bottom, because what's c minus c? 0. Now let's find the slope of RA. Now we're up here again using those two ordered pairs. And we have to do y2 minus y1. So we're going to do 2c minus 2c over 2d minus 2b. Again, what's 2c minus 2c? 0. Doesn't matter what's on the bottom, it's going to be 0. All right, we need the slope of OP. So again, we're using 0, 0 as one of the ordered pairs. So y minus y is 0 minus 0. Again, it doesn't matter what's on the bottom because the slope is 0. What did we just prove? All the slopes are equal, which makes them if the slopes are equal, then the lines are parallel. So all slopes equal. So MN parallel to OP parallel to RA. Okay, again, I'm going to draw a line because that's just the first thing we had to prove. This parallelness. Now we want to prove this. 2mn plus OP, 2mn equals OP plus RA. So what formula are we going to show now? Distance formula. And we want to see 2mn equals OP plus RA. So we need the length of these things. Remember the distance formula, subtract the x's squared, subtract the y's squared, and then add them together. So mn, again, we've got to go back to our coordinates that we're using here. Mn, we're using these right here. So that's going to be, add the x's, subtract the x's for distance. D plus A minus B. Hopefully you're not just copying what I'm writing, but you're processing why I'm writing it. I know it's kind of hard to do, but follow the formula. Yep. So I'm finding the length of MN, right? And I'm using the distance formula. And the distance formula, let me write it over here, is x2 minus x1 squared plus y2 minus y1 squared. So I have to subtract the x's using m and n as the endpoints. So d plus a is one x, and b is the other x. So I did d plus a minus b as x2 minus x1. You following, guys? Yeah, okay. All right, and then we have to subtract the y's. Here's the c is the y coordinate, and c is the y coordinate, so we're just going to do c minus c. What's c minus c? 0, so that just goes away. If I have d plus a minus b squared and then square root, what do I get? Exactly. The squared and the square root kind of cancel each other out, and we're left with d plus a minus b. That's the length of MN. Let's find the length of OP. So now we're on the bottom here again. Subtract the x's. We've got 2a minus 0 squared plus 0 minus 0 squared. Subtract the y's. Well, clearly 0 minus 0 is 0. If we have 2a minus 0, we get 2a. And it's squared and square rooted. What do we end up with? Just 2a. All right, one more. We've got the length of RA. So now we're back up here. We're going to use those two again. Subtract the two x's. So we get 2d minus 2b squared plus 2c minus 2c squared. What's 2c minus 2c? 0, so that cancels out. And again, we got 2d minus 2b squared and square rooted. What are we left with? Good, 2d minus 2b. Now we're going to plug in to what we're trying to prove. 2mn equals OP plus RA. So we're going to substitute in 2 times, what do we get as mn? D plus A minus B. Now we're going to plug in for OP. What do we get for OP? 2A. And what do we get for RA? So when we distribute, we get 2D plus 2A minus 2B equals 2A plus 2D minus 2B. Are these two things the same? So we just proved it. That's it. That's what a coordinate proof does. It takes a general polygon with variables, uses the formulas to basically algebraically prove that these properties are true. Okay, like I mentioned earlier, sometimes we are asked to use actual numbers and classify a given specific quadrilateral instead of proving something about a general quadrilateral. So let's take this one quickly. M is the point 0, 1. N is the point negative 1, 4. I'm reading right here. Negative 1, 4 is N. P is the point 2, 5. And Q is the point 3, 2. What shape do you think this is? It's probably a square. Can we tell for sure? Not really. I mean, we have to kind of prove it. So, if this is a square, what's true about it? All the sides are equal. What formula would we use to prove that? Distance. If this is a square, what else is true? All the angles are right angles. What formula would we use to prove that? Slope. So I'm going to recommend that you always start by finding 4 slopes. Four slopes gives you so much information. Mn. What side are we expecting to be the same slope as Mn? Probably PQ, so I'm going to do that one next. And the other 2 slopes then are NP, and what's probably the same as that? MQ. So we're doing slopes. y2 minus y1 over x2 minus x1. So if we're using M and N, these 2 points here, we're going to do y2 minus y1 over x2 minus x1. We're going to do 4 minus 1 over negative 1 minus 0. What's 4 minus 1? Negative 1 minus 0. What's the slope? Negative 3. Let's do PQ. Again, we're just doing the slope formula. Try to do it on your own instead of just copying what I'm writing. Think about it. PQ. We're using these 2 now. Subtract the y's. 5 minus 2 over 2 minus 3. 5 minus 2 is 3. 2 minus 3 is negative 1. What's the slope? Did we expect that? They're the same, so therefore equal slopes, so parallel. All right, let's do NP. Now we're using these 2. Subtract the y's. 5 minus 4 over 2 minus a negative 1. 5 minus 4 is 1. 2 minus negative is plus, so that's 3. So we have positive 1/3. What are we expecting MQ to come out to? Positive 1/3. So we're going to do 1 minus 2 over 0 minus 3. We get negative 1 over negative 3, which is positive 1/3. These 2 are the same, so parallel. Well, what can you tell me about the negative 3 and positive 1/3 as far as slopes go? Opposite reciprocals, therefore they are perpendicular. So what we just have proven is that there are opposite sides parallel and 4 right angles. Have we proven this is a square yet? What could it be? A rectangle. If we want to know lengths of sides to prove that it's a square, do we have to do 4 distances? Which 2 could we do? The 2 next to each other. So you could do like the distance, the length of MN, and then the side right next to it, which would be maybe MQ. If those come out the same, then you know you have a square. This one does come out to be a square.